This video is going to be pretty focused on our charging processes. In class, we reviewed 4 of those. So first we had triboelectric charging, then we talked about induction, conduction, and grounding. And when we were investigating our charging processes, we used a simulation that looked like this. And when we were doing that, we were also sort of recording observations. I sort of put names to things and then asked you all to write about the things that you noticed. That was in this document that we looked at before called Charge Behaviors, where I basically had some things for you to try out in the simulation and then record your observation and sort of come up with your own definitions for our 4 different charging processes: our triboelectric, induction, conduction, and grounding. So let's take a second to look back inside that simulation. So first, we're going to look at triboelectric charging, which occurs at the very beginning of this simulation. So I'm going to click practice again so that we go back to the beginning. And our triboelectric charging is this process of rubbing 2 objects together so that one object becomes more charged than the other, or negatively charged, leaving the other object positively charged. So our balloon, when rubbed with that sweater, took electrons away from that sweater, leaving the balloon more negative, because we know if we gain electrons, our object is becoming more negative. And the sweater becomes more positive because it's now lost electrons and now has maybe a few more protons than electrons, even though, I don't want people to be confused, no protons are being exchanged in any of these charging processes. The only reason that our sweater is positively charged, it has the same amount of protons as before, but now it has fewer electrons than it had before this process had happened. So since it has the same number of protons but some fewer electrons, it has an imbalance. It still has more protons than electrons, and now the sweater is positive and our balloon is left negative because it has protons, some positive protons, but it was neutral and had the same number. Now that it's gained some electrons, it has more electrons than protons. So that's our triboelectric charging. And it relies on a difference in affinity, or electron affinity, between 2 different materials. So something that I briefly showed in class was called the Triboelectric Series, which is what this thing on the right is. That shows a whole long list of materials, and it shows sort of what materials tend to become more positive when we rub them on something else, and what kinds of materials tend to become more negative or have a higher electron affinity. So you could think about this table as sort of like an electron affinity table for different materials. The things that are at the top that become positive have a lower electron affinity and tend to give those off, which is why they become positive, because they're not losing protons or gaining protons. Those are never exchanged when we rub 2 things together, but they tend to lose electrons, leaving back just their protons, making them more positive. And our things at the bottom of this table have a higher electron affinity, again, because they will gain electrons. Affinity is like a desire for something. If you have a high affinity for some kind of food, your favorite food, that means you want to bring it close to you, you want to buy it and consume it. That's how these materials feel about their electrons, right? Now, if we're using an electron affinity or a triboelectric series table like this, basically, let's say that we rubbed together lead and nickel. If we rub together lead and nickel, nickel is lower on this table. It has a higher electron affinity. So our nickel is going to become negative. It's lower on this table. And the lead is going to become a little bit positive. So if you rub together any 2 materials, if they are in a triboelectric series, you can predict whether or not, or whether one material is going to become positive or whether it's going to become negative. On the way that this table is set up, whatever is higher is going to become positive, and whatever is lower is going to become negative. And we practiced that a little bit in class. Now, if we come back to the simulation, the next charging process that you all looked at was induction. And when you did that, I asked you to basically bring these 2 rods kind of close, bring the balloon close by them, and you can see even before any charging occurs, right, because both of these neutral rods, or both of the rods, are still neutral, even though their electrons are bouncing around, what you can see now is a polarization process. So since this negatively charged balloon was brought close by, all of the electrons actually in both of these metal rods are pushed up to the top, right, as far away as they can from these negative electrons, the excess negative electrons in the balloon. So even before we have our charging in induction, we can see that polarization step. And it's not until we put these two metal rods in contact that they're actually going to charge each other. So here we go, induction, and now we can see that we have one -10 rod. All of the electrons from this metal rod have transferred into our negative rod up top, and leaving this sort of rod down below completely +10. It's unrealistic to expect all of the electrons to actually leave this metal rod, but for the purposes of this simulation, it's a fine illustration of how those electrons will leave this bottom one. So induction, and I want to go back to the definition that a student in class 5 came up with, which I thought was astute and is pretty much on point with what you would see in a textbook. So she wrote her observations and then her definition: a type of electrical force that that charges an object without making contact, which is exactly it. This without making contact piece is really important. That's what makes induction really special, is that this balloon did not have to touch either of those metal rods in order to charge them. It was really just sort of the two neutral metal rods that charged each other, but really it was that balloon, that negatively charged balloon, that caused all of these electrons to move up into the top rod and all of the electrons to leave this bottom rod, leaving it positive and leaving the top one negative. So that's what's special about induction, is it's that charging without actually making contact. Now that is different from conduction. So I'm going to take a second to get this rod to neutral, because we're looking at charging processes. We want to start out with a neutral rod here. So we have one rod that is neutral, it's got a charge of 0, and it's finding its way to balance out all of its positive and negative charges, but it's still overall neutral. And what we're going to do now is we're going to take this negative rod up top, and we're just going to touch it to this neutral rod. We'll see what happens. And you can see a lot of those electrons sort of bounce down into this bottom rod. And we have a -4 rod up top, a -6 rod down below. And if we really let them sort of equilibrate, they would sort of settle on this evenly distributed -5, -5, sort of like half of that -10 on this one and 0 on the other. So conduction is where we actually charge something by touching it to something charged, right? So induction, we just had to bring a charged balloon close by and offer some avenue for the electrons to either leave or enter. And conduction is where we can actually see something getting charged by touching it to a charged object like this metal rod was. Now, the last method that we talked about was grounding. So you might have noticed that I clicked this ground button when I wanted to neutralize this. This was a definition that you all came up with pretty quickly. It seemed like this was maybe the easiest charging process to talk about. And you'll notice what happens when I touch it to this ground. It goes to 0, it goes to neutral. And same with this object, right? And it's important for us to know, and we reviewed this in class a little bit, what's actually going on when we ground a negative object. And I'll do this again for a second. Charge these again, get one very negative, bring it over here. So now we've got a -9 charged rod and a +9 charged rod. So notice what happens when we touch this negative object to our ground. Notice what happens to these electrons. They are flowing into the ground, because when this object was negative, it had an excess of electrons. So in order to become neutral, it would have to let those electrons flow out of it and into this ground. You'll notice none of the protons flowed. None of the protons changed their locations at all. They're still at these 10 locations. Some of them are just hidden behind our electrons, but all 10 protons, and now we have 10 electrons, so that this is neutral. And so no protons flowed. In order to neutralize something, protons never really flow, but our electrons flowed out to make our negative object neutral. And think about how that will contrast to when we ground this positive object. We have -9. And let's think about how our charging will occur differently here, or sort of our neutralization and grounding will occur differently here. Now you can see the electrons flowing into this metal rod, so that we now have the same number of electrons and protons, making this neutral now. And you can still see some electrons bouncing around a little bit, but there are now 10 electrons, 10 protons in this metal rod making it neutral. So when we have to make something neutral that was negative, electrons flow out and into the ground from our object. And when we have to neutralize something that was positive, our ground must provide those electrons and let the electrons flow from the ground into our object if it was positive in order to neutralize it. So again, those are our 4 charging processes. We had triboelectric charging at the beginning of this when we rubbed 2 materials together. That depended on our difference in electron affinity here. So in this table, the things that are higher up, if we rubbed nylon and cat fur, our nylon would become more positive, cat fur would become more negative because cat fur has the higher electron affinity. So triboelectric charging depends on that difference in electron affinity. We went over induction, which is where we charge something just by bringing it close by. Right? Just by bringing this charged balloon close by, we can charge these 2 objects. We talked about conduction, where we can charge something just by touching it to something else that's charged. So if we charge that neutral thing with something positive, now they're both positive. And then lastly, we talked about grounding, which I just showed also, which is where we neutralize things. We allow electrons to flow either in or out of that object in order to neutralize.